Hey guys, welcome to the channel. Today is the first video which I'm dropping off, and that is about cache memory. So you might have heard about this term, which is very frequently used: caching, and everything. But where is it used, and what is caching? What is cache memory? So today we are going to talk about that. So have you guys ever went to some websites where there are so many heavy load and animations which are there? So what does happen? Every time you reload it, do you think that those load animations are retrieved every time? Those heavy animations are retrieved every time? No, basically not. So basically what happens, the web browser stores a cache. The cache actually contains all those load animations which are used, and that makes it fast to retrieve every time you reload the web pages. It is not only used in websites, but have you ever seen or observed when you run YouTube basically, and let's say you lost the internet connection? Okay, so when you lose the internet connection, but still you when swipe back to some video, you can still get some snippets of that video. How does that happen? Because your system stores some part of the clips in the cache memory, and that makes it fast to reload it again and again. So this is how caching works. Okay, but what is cache memory? What makes it so fast? What makes the cache memory fast? So the first thing which makes the cache memory fast is the closeness to the processor. What does that mean? So basically I've heard of the main memory, right? Now, before the main memory comes the cache memory. The cache memory is actually a chip based, which is placed directly to the processor. What does that mean? That makes the processor fast. That makes the retrieval fast because of the closeness to the processor. The processor, it does not have to travel every time to the RAM, right? So that makes it fast. Now, the second thing is it's built using high-speed semiconductor memory tech like SRAM. Now, what is SRAM? SRAM is basically static random access memory. Okay. Now, there are two types of memories, SRAM and DRAM. The SRAM is what makes it is what cache is made up of, but DRAM is basically what RAM is made up of. That is a dynamic random access memory, and fetching through a static random access memory is actually faster than DRAM. Now, the third point is the smaller size. Suppose you have a box, okay, you have a 4 by 4 box, and you have a 10 by 10 box, okay. Now, if I drop many balls in those both cups, so what does happen? If I ask you to retrieve a red ball out of all the yellow balls from both the boxes, what will be easier? To fetch from a 4 by 4 box or to fetch from a 10 by 10 box? Obviously the answer will be a 4 by 4 box. Why? Because the size is small, and if the size is small, that makes the retrieval faster, right? So now the fourth point is optimized access patterns. Now if you are a CS student, or you might have heard about many algorithms, many searching algorithms, right? There is binary search, there are many different algorithms you might have heard of. And in caching also, there is some optimized access patterns which are used to make the retrieval faster. That's why cache memory is faster as compared to RAM and the secondary memories. Now, the last and the most important point is coherency. What is coherency? So basically, the cache memory is not a single memory. There are many cache memories present. Okay. Now, suppose if and the cache memory basically contains many instances, right? So suppose if I have stored a variable a, it gets stored in all those instances, and let's say if I update a in my RAM, then the coherency should make it updated to all those instances of cache memory, so that whenever I retrieve it through the processor, I get the latest object. So that's why coherency is important. So now you have known why caching is important and what makes caching faster. So this was all about the today's video, and thank you for listening, and drop in comments if you have any doubt, or just ask me out if you have any questions regarding this, or if you want any clarifications on that. That's all. Thank you so much.